Hi, my name is Rodrigo Limon and I will be giving a little explanation of how I did the biopolymer modification for the removal of emerging pollutants in water. Conventional water treatments faces significant sustainability challenges due to its inability to remove emerging contaminants. Traditional adsorbents such as activated carbon, activated alumina, zeolites, and nanofibers require significant energy for production and regeneration. In addition to a high carbon footprint, new technologies such as nanomaterials, bioabsorbents, have the potential to improve efficiency while minimizing their environmental footprint. However, cost and scalability remain a significant challenge. For a proposal, we seek a chemical modification methodology between chitosan and lignin to create a new nanomaterial available to remove emerging pollutants from water streams such as paracetamol or pesticides. For the methodology, you will need to prepare the mother solution. This will be 200 milliliters solution, 50% water and 50% ethanol. Separate 100 milliliters of the solution, add 2 grams of chitosan. Then separate other 75 milliliters and add 2 grams of lignin and 2 grams of DATMAC. Then mix both solutions at 600 revolutions per minute for at least 10 minutes. Then you will need to mix both solutions into one beaker and mix for at least 30 minutes at 60 degrees Celsius and 1000 revolutions per minute. Then add 1.75 grams of benzoin. For radiation, you will need to take the solution into a microwave in periods of 30 to 60 seconds with 160 watts power to a maximum of 320 watts until 70 degrees Celsius is reached. Keep the mixture for 8 to 10 minutes at that temperature. Do not exceed 75 degrees Celsius. Then, for the extraction of the biopolymer, you will need to remove the supernatant and the liquid. Only leave the bottom solid, and then you can dry it at 50 degrees Celsius for at least 2 hours. After the radiation process, the bottom layer CLB and the top crust were examined, showing a modification in the CLB characterized with nanoparticles with chlorine evenly distributed, as we can see in the yellow image on the right, which corresponds to the third image that says biopolymer surface. The bottom layer, CLB, and the top crust were compared in the DSC and FTIR analysis to the physical mixture of the components without any radiation treatment. The FTIR analysis, the crust and the mixture appear to have similar compositions with no changes in any characteristic line. But on the other hand, the CLB and the mixture in the FTR have significant changes that are characteristic of DATMAC, meaning a possible graph between chitosan and lignin. Besides the SM, DSC, and FTIR analysis, also there were some emerging contaminant removal trials, in which the CLB has the capacity to remove up to 15% of paracetamol and pesticides. To sum up, nanostructures of grafted lignin particles into the chitosan surface appeared after radiation. Also, the presence of chlorine, only found in DATMAC, is homogeneously distributed between lignin and chitosan. And a 15% removal of paracetamol and pesticides was obtained after the CLB radiation. Also, for future work, it is necessary to find a method to extract purified biopolymer and make more trials for the removal of emerging pollutants. Also, it is necessary to obtain the maximum regeneration capacity for the biopolymer.